Welcome back, everybody. Example 6.3. This is going to be part B, where we calculate the acceleration of the pail. Now, I've started on a new blank page right here, but I'm going to quickly kind of recap what the original problem was right here. So we have our pail, all right, and it's experiencing an 11 Newton force, we'll call that F2, from Jill, all right, and that's at 62 degrees from the horizontal. And we have force 1 from Jack, which is 7 newtons, and that we figured out in part A is going to be at 42 degrees from the horizontal right there. This pail is also experiencing a force due to gravity. We're going to call Fg, or sometimes we call it W for weight. A little bit later, I'll show you how that's calculated. But that force is going to be 12.8 newtons. So we established already in part A that the x component, F2x, and then the F1x, they have to be balanced out, because the pail is not moving side to side. It's only moving up or down, hopefully up, because they're trying to pick it up. All right, so we can pretty much ignore the x components now, because we used them in part A to figure out this angle right here. What we really want to focus on now is the y components of their forces. So we have force 1 in the y direction and force 2 in the y direction. That's really what's going to be picking up or serving to lift up the pail right there. So once again, we need to establish a coordinate system. So what's positive and what's negative in the y direction, since we're basically ignoring the x right now? Well, I think it makes sense that up would be positive and down would be negative. And so let's sum up our forces in the y direction. Okay, so we have a positive force 1 in the y direction, and we got a positive force 2 in the y direction, but our weight force, or the force due to gravity, is going to be negative. Now we're told what that is. That's 12.8 newtons. Okay, but what we have to do is do a little bit of digging to figure out what our y components are of force 1 and force 2. Well, we have the full magnitudes and we have the angle right here. So to find the y component of an angle based from the horizontal, for force 1, that would be, what's the magnitude? 7, and then we have a sine of what angle? 42 degrees, right? That's Jack's y component of his force right there. And while we're at it, we'll write down Jill's, and then we'll just calculate them all at once. Jill's full magnitude is 11 newtons, and that's at an angle of 62 degrees. Finding the y component, we use sine, 62 degrees, and that'll give us our values for force 1 in the y direction and in the x direction. So 7 sine 42, that gives us 4.7 newtons, all right? And then 11 sine of 62, that's 9.7. All right, and they're both in the positive direction because Jack and Jill are pulling upwards, kind of, but the y component of their forces are going to be positive. The only thing that's acting against their upward pull is the downward pull of gravity, the force that is created by gravity, the acceleration of gravity pulling on the mass of the pail. All right, so let's add them up. All right, what is the net force in the y direction? In fact, I already have it written up here, right up there, so I'm just going to continue. Let's add up all of our values, so of forces in the y direction. So 4.7 newtons plus 9.7 newtons. And then we have our 12.8 newtons down here acting in the negative direction, so they're acting against the other two, so we're going to put a minus right there, 12.8 newtons right there, and that'll give us a total of 1.6 newtons in the y direction. That is our net force in the y direction right there. That's important to find, because if we're going to find the acceleration of the pail, and it's only accelerating in the y direction, In order to find that, we have the mass of the pail. We need to find the net force in the y direction of the pail, and that's what it is, 1.6 newtons. No, the rest of it's going to be easy. It's just going to be Newton's second law. All right, recall so that the net force in the y direction equals the mass times the acceleration in the y direction. Now, one thing you need to be careful of here is that you're used to looking at the acceleration of the y direction and saying, oh, okay, well, that's gravity, that's 9.81. Well, no, it's not going to be, because this value right here is already accounting for gravity. Gravity is trying to pull it down, and so this 12.8 newtons, gravity is worked into that. What's going to happen, like we're actually told in the problem, is that it's going to accelerate upwards. So this acceleration right here is going to be something different. It's going to be something that is caused by Jack and Jill pulling upwards. So let's just change or turn it around and solve for acceleration in the y direction. All right, so it's going to be the net force in the y direction divided by the mass of what? Oh, the mass of the pail, right? Because that's the thing that is being accelerated right here. So the net force in the y direction is 1.6 newtons. The mass of the pail is, I believe, 1.3 newtons. In the simple bit of math right here, 1.6 divided by 1.3, it's going to be 1.23. 23 what? Well, it's an acceleration, right? So it's meters per second squared. That is going to be our acceleration of the pail, because only the y components of Jack and Jill's pulling are going to be working against gravity. They're pulling at the correct angle so that the x's balance out, and so what's left over is the y components overcoming gravity just enough so the pail accelerates upwards at 1.23 meters per second squared. That's a good application of forces in x's and y directions acting against or with each other, and so that's our acceleration right there. So I hope that helps. Please let me know if you have any questions on this, and I'll see you on the next one. Thanks for watching.